Do you know what a fusion crust is? This meteorite is covered in it. We can even look closely and tell the orientation of the meteorite as it came down to Earth. Let's talk about it and learn about the Hamada El Hamra 346 meteorite, commonly known as Gadamus. This meteorite comes from the Hamada El Hamra region of northwestern Libya. We're talking about a rocky plateau area of the Saharan desert. Now, this is believed to be associated with a 2018 witnessed fall. We say it's a possibly witnessed fall because there are reports of people having seen a meteor streaking through the sky, but these are not verified fully. There's no video of it, nothing like that. One of the reasons we suspect that this meteorite may be from that observed fall is because of the fusion crust that's present on it. Now, we've talked about fusion crust on this channel before. It's effectively where when the meteor comes through our atmosphere, the outside of it burns up and it chars the outside of it and creates a very thin layer of this black, matte, almost frothy looking outside exterior texture of the meteor before it lands on our planet. The thing about fusion crust, though, is that if the meteorite is left untouched on Earth, particularly in the desert, it will wear off. If you think about a desert environment, you have a lot of wind and you have sand. So effectively outside of the meteorite is getting sand blasted, and that effectively removes the fusion crust over time and often leaves what we call a desert varnish. Even if this specific meteorite wasn't part of that 2018 fall that a lot of people reportedly saw, it is certainly a fresher meteorite, one that has fallen more recently, or else the fusion crust wouldn't look so incredibly well preserved in this case. This meteorite couldn't have fallen very long before it was picked up by people and preserved and taken out of the harsh desert environment. My personal specimen of the Hamada al-Hamra 346 meteorite is the one we're looking at now. It's about 550 grams, and I absolutely love it because you do have this really brilliant fusion crust, and because this is an L6 meteorite, so it's kind of recrystallized, we don't have all those obvious chondrules, we kind of have this white texture underneath it, and you see where chunks or chips are kind of ablated off of it, probably during flight or when it landed. So we have that white interior exposed, which makes the black fusion crust really pop and look really visually amazing. With this specimen, you can also tell that it's flight oriented. So it has a little bit of an aerodynamic shape. And if you hold it under the right light, you can see little lines trailing off of it. And those are what we call flow lines. They indicate the direction that the meteor took as it was coming through our atmosphere. That's effectively the melting of diffusion crust that creates those lines, almost like you would think of moisture running down the hood of a car when you're driving along or when that car is in a wind tunnel or something. The Gadamus meteorite is one of my absolute favorites to show people when I'm talking about fusion crust and what happens to a meteor as it burns up entering our atmosphere. If you like learning about space and want to learn more about that through the lens of meteorites and meteorite science, make sure to give me a follow and like. I've got a ton more to share with you.